convert to a radical expression? It's simple. So when you have a rational exponent, the numerator represents the power and the denominator represents the index. So for example, my power is 1, my index is n. So when I write it as a radical, n is on the outside and my power is on the inside and it's just a 1. So do I have to write 1? No. So let's look at it with numbers. So here I have 9 1/2. My power is 1. My index is 2. So on the outside, it's 2. On the inside, I have 9 to the 1 power. Well, what is the square root of 9? 3. So this simplifies down to 3. Okay. Here I have 8 to the 1/3. My power is 1. My index is 3. So on the inside, I have 8 with the power of 1. On the outside, I have an index of 3. What is the cube root of 8? 2. Why is it the cube root of 8? Because 2 times 2 times 2 equals 8. Okay. So that is how it's done. So the best thing I would say to remember, get your power over your index. Guys, equals your index and your power. Or if you don't want to put it in that way, you also can write it vice versa. You can do the index and then the power. It doesn't matter. I personally like to make my number small and then multiply. I do not want to make a big number, then break it down. Just sounds wrong. All right, now we're going to remember some things from Algebra Uno. In Algebra 1, when you have two numbers that have the same base, what do you do with their powers? You add them, okay? When you're multiplying two numbers with the same base, you are adding their powers, their exponents. Do you remember that? All right, that's rule number 1 from Algebra 1 that you should have walked away with. The other rules that you should have walked away with is if you have a negative exponent, that means that it actually belongs in the denominator. If you have a negative exponent in the denominator, that means it actually belongs in the numerator. So these are vice versa, versa. You know what I was trying to say. All right. When you have an exponent times an exponent, you literally just multiply. M times N. And distributing powers, each base gets the power. You don't just distribute to one, you distribute to both. Do we remember these things from Algebra 1? Okay, so we're going to be applying those skills and knowledge. All right, on your notes, I made a little mistake. I should have written exponent, then radical first. It doesn't really make a difference, but just know that it should have been exponent, then radical. So I'm going to write exponent so that you know that I'm working underneath the exponent side. And then I'm going to work underneath the radical side. Does that make sense? All right, so underneath the exponent side, I see that I have two bases that are the same. So what am I doing with their powers? I'm adding them together. So it becomes 36 1/4 plus 1/4. What is a quarter plus a quarter? A half. So I have 36 to the half. Does that make sense? So that's the exponent side. Now the radical side. 36 to the half is what as a radical? It means that I'm taking the square root of 36. Why? My power is 1, my index is 2. So on the exponent side, this is the furthest I can simplify, but on the radical, I can completely simplify and solve. So what is the square root of 36? 6. What are your questions? Huh? 1/4 plus 1/4 equals 2/4. And what is 2/4? A half.
Wait, where did the other 36 go?
What other 36?
36 times 36 1/4.
It's 36 to the half, or right here when you combine them.
Okay.
When their bases are the same, to combine, you add their powers.
Okay, you don't have to do 18 to the 1.
Mm-mm. They become one. They condense. All right. Questions about, shh, guys. The people who are talking, I hate to say it, are going to be the main ones asking questions later. Well, then ask me. That's what I'm here for. Then you've got to take those notes. Those notes actually aren't going to affect you right now, so you're okay. All right. Questions about example 1. Example 1 would be the baseline, the easiest it'll be. So if you have questions about example 1, please ask them now. Okay. Example 2. So again, we're going to work under the exponent side first. Notice I have numbers now. All that means that you're going to multiply first. You're going to multiply first and then deal with the exponent. So we have 6 times 2. And my bases are the same. So that means I have 2/3 plus 3/4. Well, what's 6 times 2? 12. Uh-oh, we have a flag. Can I add these straight across? No, why not? They do not have the same denominator. Because they do not have the same denominator, I cannot add straight across. So I have 2/3 plus 3/4. What I'm going to show you is a shortcut to add with fractions are have uncommon denominators. So we have 2/3 plus 3/4. Now, if you're good and quick at finding common denominators and going through the process, awesome. If not, here's a little shortcut. It's very similar to proportions, but it's not proportions, okay? Because there's no equal sign. So we're going to cross multiply. 2 times 4, 8. We're going to add. We're going to cross multiply. 3 times 3, 9. And then we're going to multiply the base, the denominator, 12. So 2/3 plus 3/4 equals what? 17/12. Okay, I call this chopsticks in a bowl. Why? Because it looked like chopsticks in a bowl when I was in 10th grade. And that's what I rolled with and called it a day. Anything I can make related to food works. Huh?
That'll work no matter what.
It works no matter what. You may have to reduce, but it works no matter what. Okay, so what is 2/3 plus 3/4? 17/12. So we have x to the 17/12. And this is your exponent form of it. Simplified as it can get. Your fraction is reduced, your numbers are combined, right? All right, so we're going to do the radical form of it. Okay, so radical. When you have a radical, this is telling you how many, we talked about this we did talk about this. How many times is 12 going to 17? Once. So on the outside, you're going to have 1. And then on the inside, how much are you left with? What's the remainder? 5. So x to the 5th. And what is your index? 12. So when you're converting this, you have x 17 over 12. You're asking yourself, what is you're dividing? 12 goes into 17 one time, and it had a remainder of 5.
Are we getting 12 from the index or the whole number?
The 12 is your index.
Okay.
Yes. That just so happens to be 12
What you're
also,
dividing by 17.
is the index.
Okay.
It's your power divided by your index. So your power divided by your index. And the remainder stays inside. Because remember, your index we talked about is how many you want in a group. So in a group, I want 12 x's, and I only can make one group of 12 x's. And so I can only take one group out, and what's remaining would be 5 x's. If you, some of you may need a visual, I will gladly do the visual. So what this is telling us is that we have an index of 12 with 17 x's underneath. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 7, 8, and boom, 17, right? And your index tells you how many you want in a group. Well, if I wanted to make a group of 12, I would take out, I could only make one group of 12, right? So I could take out, and what would be left on the inside? 5. So I made one group, and our remainder is 5 x's. And that's why it's x with remaining 5. Does the visual help?
Yes.
Okay. And that would be your radical in simplest form. Okay, so this is your exponent in simplest form, and that is the radical in simplest form. I hope the visual helped. Asking me questions helps me help you, okay? So good job, Fox. All right. Here we go. Now we have 8x to the 9 times y to the negative third to the negative 2/3. So what am I going to do with this power?
Oh, it's the denominator.
You distribute. You get a negative 2/3. You get a negative 2/3. You get a negative 2/3. We all get a negative 2/3. So under the exponent, we have 8 to the negative 2/3 times y, not y, I skipped x. Lo siento. We have x to the 9 times negative 2/3 times y to the negative thirds times negative 2/3. Okay, 8 to the negative 2/3. What does that mean for 8? Well, 1, it's negative. So that tells me it belongs where? In the denominator. So it's 1 over. And then my power is 2. My index is 3. So it's the cube root of 8 squared. And it belongs in the denominator. Next, I'm going to do x. 9 times negative 2 is? Negative 18 divided by 3 is? Negative 6. So this equals negative 6. So what does that tell me x belongs? In the denominator. So it's 1 over x to the 6. Negative 3 times negative 2 is? 6 divided by 3 is 2. So this is just y squared. What is the cube root of 8? And what is 2 squared? 4. So now putting it all together, in the numerator, what do I have? Y squared. In the denominator, what do I have? 4x6. And there is no radical form of this because I have no rational functions left, no rational exponents. Hey, you do on your phones and whispering. What are your questions?
Are you supposed to simplify these fractions?
If they're simplifying, yes, but there's nothing to simplify.
Okay, so if you can, you should simplify.
Yes, that's why it says simplest form. Antonio. Huh? This is a rational exponent. When you have a fraction as a power. Yep. All right, and so there's no radical form because there's no rational exponent remaining. All right. Okay. This is not what this problem is supposed to be. Why is my problem the same? So it should be 16z to the 4 divided by 25x to the 8th, right? To the negative 1/2. There we go. All right, so we're gonna do the exponent first. And if there's a radical, there's a radical. If not, then we are good, right? So you're gonna distribute, 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 distribute. So notice that that power is going to every number and variable in the numerator and in the denominator. So we have 16 to the negative 1/2. We have z4 times negative 1/2. We have 25 to the negative 1/2. And we have x8 times negative 1/2. Okay, the negative lets me know that everyone is switching. Does that make sense? So what's in the numerator needs to go in the denominator, and what's in the denominator needs to go in the numerator. Does that make sense? So this is going to move me to have the square root of 25. And I'm going to have x 8/2. I'm going to have the square root of 16. And I'm going to have z 4/2. Why did I write these as square roots?
When I thought you were supposed to simplify the x. Like
I am. I just didn't want to skip a step. Okay, so here it's your index and your power, right? What is the index here? 2, right? The power is 1. So it's just square root of 25 and square root of 16. Okay, what is 8 divided by 2? Well, what's the square root of 25? I'm sorry. What's 8 divided by 2? What's the square root of 16? What's 4 divided by 2? Do I have any remaining rational exponents? No. So is there a radical form? No. All right, questions? Yes. I need a question. That's a statement.
Okay, so like at the beginning, so they're like, what is the switch?
Because their powers are negative, that means they're not happy. They're in the wrong location. So everything that's negative in the numerator belongs in the denominator, and everything that's negative in the denominator belongs in the numerator, which is why we moved them here. So negative 1/2, negative 1/2, negative 1/2, negative 1/2. That's the second and third rules at the top of your notes on the other side. Okay, so we're going to do 2 problems at a time. So I would like for you guys to try the first 2 problems, and then we're going to check. Why are you doing 25? It's just 5. The base stays the base. You only are adding the powers. All right, guys. Let's see how you did on 1 and 2. So on number 1, your bases are the same. So because your bases are the same, you're going to add the powers together. So you have 1/3 plus 2/3 makes 3/3. And what does 3/3 equal? 1. And what is 5 to the 1 power? 5. And then on number 2, you're going to multiply your numbers first. So you had 6 times 2. Then you add your exponents because the bases are the same. So I did a little chopstick and bowl action. And I got 7/12. So that leaves me with 6y 7/12. As a rational, can 12 evenly divide into 7? No. So I have my index is 12 and my power is 7. So you should have gotten, because you don't multiply the bases when you, so remember the first thing I said in the very beginning, if your base are the same, You are adding the powers. That was, so y'all remember this in algebra 1? Okay, when your bases are the same, you are adding the powers. Are you doing anything else to the bases? You're just adding the powers. All right, the last two until the bell. All right, guys, so checking your 3 and 4. So for your 3 and 4, you should have gotten -11 as the exponent. For number 3, that's because the bases are the same. So what are you doing with the powers? You're adding the powers. So that's 1/3 plus 1/3 plus 1/3, which makes 3/3. Okay. On number 4, you multiply your numbers first. The bases are the same, so you're adding the powers, the exponents. So we have 1/6 plus 2/6 is 3/6, and that makes 1/2. Okay, we will resume the practice tomorrow.